Hello and welcome to this video. This is about the Riemann zeta function and how you can implement and explore the function in the R programming language. First of all, think of the zeta function just like any other mathematical function. You pass a value into the function and then it gives you another number or another value back out. The values that go into this function are complex, and the values that come out are also complex, which is why these output values are being plotted on a plane here on the XY axes. The real axis goes from left to right, and the imaginary axis goes from top to bottom. The values that I'm putting into the zeta function here are real values a half, and imaginary values start on 0 and then they go up in steps of 0.1 or 0.01, and they go up all the way to 200 actually. So values, imaginary values on the critical line all the way from 0 to 200. And as you can see, the output is going through the origin multiple times, and each one of those is a critical 0. So if there was any kind of important idea that I wanted to get across here, it's that these values coming out are going through the origin at the critical zeros. Towards the end here, I think it's going wrong. I think it's losing accuracy. So let's have a look at the calculations that are happening here. The zeta function is a function that takes the input s, where s is a complex number. And this is what I really want to show you. This is the zeta function that we use for real number values, real values of s. So zeta of s is the sum from 1 to infinity of the reciprocals to the power s. So the famous example is 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared that Euler proved way back in the day was equal to pi squared over 6. But the problem is, if the real part of s is less than or equal to 1, you have a problem. So you actually have to use this formula here, which works for any complex value of s. So as you can see, s goes into the function, but you have to do some pretty tricky things, like 2 to the power of 1 minus s, and then taking the reciprocal of 1 minus that complex number, and also minus 1 to the power k over k plus 1 to the power s, where s is a complex number. And when I looked at this 3 or 4 years ago, I was just too scared of it. I just thought there's no way I can do these kinds of complex calculations. But this time round, I wrote my own functions, got the code to work, and then discovered that I didn't need to do it. And that's because in R, you can do things like this. Z equals 1 plus 2i, 1 plus 2i. And then A equals Z to the power Z. And then print A. Look, it just handles it. Base R can handle complex numbers. So you can just concentrate on writing the code, and R handles the complex number aspect of it. If you want to see my code, there's a copy of it on my blog, and you're welcome to borrow the code. And I'll put links to all of these things below. Oh yeah, and finally, I just wanted to show you the zeta function working on some different input values so that you can see what happens when you just run the zeta function bit. So for example, the zeta of 00 is minus 0.5 real. The zeta of minus 2 is a very small number because that's one of the trivial zeros, and the zeta of minus 4 is also a very small number. And if you keep doing minus 6, minus 8, all of the negative even numbers, you get zeros. Here, this just shows that you can have a real value of 1 and still get a sensible answer out of this zeta function. And then we got some interesting ones. Zeta of 2 is pi squared over 6, which is Euler's famous result. Zeta of 3 is 1.202, which is a really good mystery to look into. The zeta of 3, and can you find an exact value for the zeta of 3? zeta of, and now these are critical values. These are on the critical line and they're non-trivial zeros. So 0.5 and 14.13 is a very small value. Here's another non-trivial zero, very small number. And then all of these values that are on the critical line that should be zeros are zeros. So from my testing, it appears to be working well, but I'm just worried that number of iterations 200, this loop here that goes from 0 to number of iterations should be going on forever to get perfect accuracy, but you can't do that in a computer program. So I'm just doing, in fact, in the animation you see, it's just 100 terms. And I'm wondering if that's why when it goes beyond about 150 on the imaginary axis, it starts to lose accuracy and it doesn't go through the center anymore. Those are my thoughts. What are yours? Please comment below. Thanks a lot. Bye.